Ah, okay. You should be able to hear me now. Sorry for the noises before. I wasn't sure if you could hear me. I do think I'm gonna put that a bit down so you can hear me over it. You can tell me if something to change about the setup. Okay, I think we are... It's about time, so I think we'll go ahead and call it. Yeah, just turned 8 o'clock, so we get started today. Welcome to the stream. It's been a while. It has been a while. And today we're not gonna be doing any of the normal Minecraft stuff because I have exams. I need to work on my exams. So for today, let's change the scene, and I can show you immediately this button. There we go. Yep, we're gonna do some programming today, which is gonna be interesting. So before we get into that, I first want to talk a bit about what all happened in between the last stream and this stream, because it's been a while. So first of all, how was your day? Mine was pretty good. Had an exam today, nailed it, absolutely smashed the exam. That music is a little bit too loud for my taste at my end, so I'm gonna turn it down a little bit because it is absolutely killing my ears. Jesus. Okay, but now it will be too... Okay, so let's turn this one up. And then you can let me know if anything needs to change, if anything needs to be a little bit louder, a little bit, well, more silent. But as I was saying, I had a pretty great day, had an exam today, absolutely smashed it out of the park. It was a brilliant exam, really well, I mean, it tested our knowledge of the C++ language, but we were allowed to use the internet, so we just needed to be able to, to just apply everything that we've learned this semester. And it was a really good exam. I really enjoyed the exam actually, which you can't say for most of the exams, but this one was quite fun. So what are we gonna be doing today? Actually, no, I've got a couple of things else to show you before we start, because I know this is homework, but I wanted to make it a little bit more interesting. So, if you don't know, every time you want to apply an application that you're developing, you need to build the application. So, if I press the start button over here, or if I do the shortcut for it, I need to build the program. And then you can see at the bottom of the screen, it starts showing a lot of output. And that got me into an idea, because the holidays have passed around, and I got a lot of holiday gifts. So let's go over them first, and then I'll share my idea for the challenge. So first of all, I got a lot of books, because I like reading manga. So my family gifted me some manga. I got a couple of new volumes from like Tokyo Ghoul and Assassin's Classroom, which are two of my favorite series. Can you see this? I don't know. But these are fun. And this, I think, the Tokyo Ghoul one it's volume 5, and it has my favorite scene of the whole series into it. So that's pretty cool. Got some other books as well. Got some gift card for some books as well. But we can talk about that a little bit later. What I want to talk about is some of the gifts my family gave me on the New Year's, and that was two things. First of all, they gave me a little statue of Harry Potter, little Funko Pop, which I really like. I didn't expect them to give me something like this. This is really cool. So this has been standing on my shelf for the last couple of weeks. It's been really awesome. And then I also, together with that, got these little guys. And this is where the challenge part comes in today. I received some of these Berry Bots beans, which is beans in every kind of flavor, and there's a lot of them. They are all in the package. But my idea is to make it a little bit more interesting. Like these beans, right? Every time my project doesn't build, so every time it says on the console over here, build failed, I'm gonna randomly eat one. And there's some really crazy tastes in here. There's like There's like good ones. There's like blueberry or cherry. But there's also like rotten egg. There's also one called vomit, and I really don't want to try that. But oh god. So it's gonna be interesting. It's gonna be interesting. Okay, on to what we're actually gonna do today. So, for my course of gameplay programming, I need to make an AI that will survive in a zombie survival game. So, I can actually show you the game if I press the run button here. It will load up. I'll drag it into screen. You should be able to see that hopefully. And you can see our little dude here, the green guy. That's us. That's the guy we're gonna program. And he can get information from everything in his yellow segment over here. Everything in there he can see. All the rest is just he can't perceive. And based on that, we need to make him live as long as possible in this world. There's zombies. There's orange guys and yellow guys. There's houses with stuff in them, which you can all use. And then once you die, you're dead. And we're gonna program the AI for this little green fellow over here, and hopefully it'll survive a little bit longer than when he's just moving around randomly like he is right now. And there's things to make it a little bit more tricky, so there's food, there's health, there's energy, you can start running. It's actually a really complex game, but we'll get into that once we actually start working on it. So I think we actually can start working on it. If anything is unclear about the code, I'm not gonna teach you how to program, unfortunately, but I'll try my best and explain as good as possible what we're gonna try and do. So, this is a guy over here, and as you can see, he's wandering around aimlessly right now. He's just doing it randomly. So I wanna fix that. But first of all, before we can fix that, I first wanna perceive everything that is in our little vision cone here. And there are some functions for that. That can get like everything that is inside that vision cone. I just put it on my screen, you can't see that. So there's some functions for that can get those variables and stuff, but we need to save those, and actually we died now. So we need to save all of those things that we perceive and store it in our brain. So that's the first thing we're gonna focus on. Okay, so let's go over to our plugin file. So what we're gonna do, this variable called Blackboard, that's where we're gonna store all of those variables in. So we can add a variable here at the add data, and then we can give it a name. So let's see, what can we all store? First of all, let's store like everything. What can we store? Let's do all of the houses. Okay, so all of the houses, this we call it houses. This will need to be a vector of some kind. And I already picked a tricky one. So this houses, we have some information that we can get from like the vision code. And it's, where is it? House information. Isn't there like house information? House information. So we can get the center of house and the size of the house. But I also want to keep a value that tells me if I'm actually visited that house or not, right? So I can't change this code, so we're gonna have to make a new struct for that. I already have it right here set up. So this will keep that house info that we get from the vision cone, and then we add a boolean, which is just a value that's true or false, and then we say if we have visited or not, and then this reset time, I'll explain that later on. So we're gonna have to add a vector in here, but I also want to save this here, so we'll make the vector here. So let's set here data variables, and let's make that a vector and house. Give it a reasonable name like mhouses, and it will start empty. Of course it will start empty because at the beginning we haven't seen anything, and then we can link those two together. Houses, there we go, and that's houses stored into that array, into that blackboard, right? And the blackboard again is where we can get where our AI can get information from. Okay, but now we need to get the information from our vision cone and store it in that house vector. So to do that, we got a function get houses in field of view, which does exactly that. The only thing we need to change about that function is that it should, well, this first of all gets like the basic struct, not the extended struct that we just made. And then on top of that, if we already have the house in our vision cone, we don't need to store it again, right? So we need to check that as well. So we're gonna make a new function to do that. Let's call these helper functions. And we're gonna start with a void function, so that a void just means that it doesn't return anything. And let's call it update houses, right? Okay, so that will take no information. And okay, so we can make that, so void houses, void plugin, because I call houses, update houses. Okay. First thing we need to do is get that vector. Let's just do auto, that's gonna be easier, auto houses in, well, call it new houses. So this is the houses that we can see, and we're gonna do that by get houses in field of view. Right, so this just gets all the houses in the field of view, stores them in a vector. Now for each of these, I can do a for each loop, so house info. Let's actually make it a constant house info reference to house in new houses. Okay, so now we got, for each house we need to check if it's already stored in our array, right? So if, okay, so how do we, hold on a minute. Now these houses never change, so once we've actually received them, okay, we don't need to do it again, otherwise we need to push it back again, right? So, it's cool music though. There's some kind of algorithm for this, I know it. I'm just trying to find out which one it is. I think it's find if. We can do that. Let's just try find if. Find if. So we need to check the houses from the beginning, of course, to the ending. And then we need to check, we need to say when it needs to find the items. So I'm gonna do that with a lambda, which is a little bit advanced. So we need to do, hold on, how does it work in this? We're just gonna say that, doesn't matter really. Okay, it does matter. Okay, and then auto element, so that will check for the element. And then when do we need to find it? It's just really easy. If house.location, house.center is equal to the elements dot house info dot center, right? And I think that's within capitals. Don't know if the house info is. I need to pay attention, because if I fail this, well then I need to do a jelly bean, and I don't think that it's a bit too easy for that. Okay, so find if this returns a iterator, right? Okay, so auto iterator, and if that iterator is equal to, I should put brackets around this, is equal to the type iterator, there we go, that's better. If that iterator is equal to m.houses.end, means it didn't find one, so the house that we're checking is not in the in our list of houses, so we need to edit, so we need to push back into the array a new house info extended with house info, of course. And then we need to say visit is true, and that time doesn't really matter, we're gonna just put it at 0 to be complete. So again, let's comment this. Get all the new houses, the visible houses. Then check each visible house. If it's already known, is it already known? I'm just gonna call it, is it already known? If not, add it to the array, to the vector. Okay, I think we need to now add that to the update, right? So we're gonna make a new function here to collect data. We're gonna just keep it at one function for now, because we only have this one function, so it doesn't really matter to put it in another function. Okay, then I'm gonna update the brain. That's how we're gonna do. So that's not gonna change anything to our actual output. But now we're keeping track of all the houses that we have seen. And we can actually check that, so I'm gonna check at the end of this function. If this has happened, right, then we're gonna be able to see it. So let's see. It should actually recognize this, so there's something wrong. Oh, I'm running in release mode, that's the problem. Okay, let's actually run it in debug mode. Let's put this back to debug as well. Let's build it again. Let's see if the build completes. It should. It failed. Oh shoot. Okay, so that means I'm gonna have to put it either jelly bean. That's gonna be fun. Okay, that's awesome. But first I need to figure out what's wrong here. It's something with the template, so it's something with this find if function. Oh, of course, it needs to be a return statement. Oh, that's a stupid mistake. I need to build it first again. So we're building it. Now it succeeded. Okay, perfect. Let's try and start the project up. Where's my... Okay, it's loading in. Okay, it did already detected the house, so that's good. So it's working. It detected another house. I can't show you this, right? Continue. Okay, let's see. Now it's gonna be stuck in here because it's just wandering, but as you can see, if we actually pause it, we've detected 2 houses. Oh god, what is all this doing? Okay, we're not gonna bother with that. Just believe me if I say it's working. Okay, good. This is not the content you sought for. Well, it's still me, no? Right? You're coming at the right time. I set myself a challenge, and I failed the challenge. So I need to be punished now. And for punishment, I've got these jelly beans. So let's change the screen to the big window. I'm gonna open this up. Let's see if I can open it up like... Oh, I'm gonna have to get either scissors or... Do I have scissors? I have scissors. Oh, perfect. Probably the first time I'm using scissors from my desk. Let's cut these open again. Right, okay. Okay. So... Oh, this is gonna be terrible. Okay, I got one. I don't know which one it is. It's the yellow one. I'm gonna do it like this, like this. Can you see that? Right. This is what I'm gonna have to eat now. Yeah, it's closer to my mind gummy bear bag. It's beans. It's like the every flavored beans from Harry Potter. So this one could be bad. Oh, it's a banana. Oh, we're fine. It's banana. I think. It's banana. Shaved. I'm still alive. I'm back to coding. Back to doing homework. Okay. Perfect. So now we have the houses. Okay. That's it. Now, if the house is not the only thing we need to save, right? We also need to save all the items we come across. So we're gonna do the same thing for the items. Call it items. We're gonna call this M items, but then we also need to make that array, or make that vector. Excuse me. So where is it? This one. But then this time it's gonna be item info, right? Item info M items. Perfect. There we go. And then we're gonna do the same thing, but we're gonna do update items. Man, I can't type today. Okay, perfect. Two. Okay, so we do that. Okay, now we need to do basically the same thing. So I'm just gonna copy it. We only need to do one more check, but I'll explain that in a minute. Just gonna do items here. You get entities. It's called. Fill the view. I should item info. Item. And new items. Right. Items begin and auto element item dot location equals item. Element location. There we go. And items. Then we push back the item. Okay, it's a little bit simpler. Although it's not in M houses, but in M items. But there's a couple of other checks we need to do. First of all, okay, so this gets all items, right? But the function also, how to explain this? So the function gets all of the entities in the scenes, and the entities includes more than just the item. It also includes the enemies and something called a perch zone, which I'll explain later on. So it's actually not item info type, but entity info type. And then before we can actually check if it's already in the array, we first need to check if the item we are checking is actually an item. So we'll call this entity. And then we're gonna cast that entity. So if entity.type no, oh my god, I can't type here. That should be entity. Entity.type is equal to entity type item. And then we can check all of this, right? Okay. So first of all, we need to constitute an item, and how we do that is by doing it with the interface. So this is basically that field of view interface, and then we are gonna where is it? Item.getInfo, and then we have to make an item info item. And then what this will do is, that's a function that will fill in that information for us, like this. And I think I put them in the wrong order. Okay, so if we have not found it, we should add in the factor. If we have found it, we need to change the value, because the value that's already in there, we need to change that because these this whole framework is made so you can't cheat, so everything is rehashed every second. So everything you got from the previous cycle is actually in an invalid state, so we need to update it if we see it again. So to do that, so else, this means that we have found it. It is already there. And then we put at that position which the iterator is at equals, oh no, we can actually just do iterator equals probably. Hold on, I'm thinking how this works again. Oh, I think it's easier. It's just m.items.iterator. How do iterators work again? Oh, this is becoming my brain. The item at the position there. Oh. The value is equal to item. Does that work? That works perfectly fine. Okay, that's how it is done. Perfect. So now every item we encounter, we also store in an array. Good. I think that's all the information we need for now. So then, we can start by actually moving around the let's see if it builds. Let's see if I have to eat another jelly bean or not. It succeeds. Jelly beans wait. So now we're gonna actually add in some logic to this thing. So we're gonna make it look for like, I think the easiest thing is first of all to make it so we're gonna first make some default action here. How is this done again? Oh shoot, I shouldn't have removed all of them. It gives back a state, but I don't know which one it is. Behavior tree state? I don't know which one it is again. Hold on, we can look this up. Let's look in the framework and then the behavior tree right here. Behavior state, that's how it's called. Isn't that exactly the same? Let's copy this up. And set to wonder. Turn. I'm a little bit confused here in success. I don't know why that's not working. Behavior tree is in here. Is that in another? Oh, that's in the elite. Okay, there we go. It's in a namespace. And it's a stupid way of success. There we go. Okay. Okay. So, first of all, let's check something here. Okay. So, one thing we need to do is we need to say to the AI how it should move. And how we do that is by adding another variable into our blackboard here. Let's add some variation. And let's call it current steering, which is the current option of our steering, which is a steering behavior. Here, steering behavior. Empty one. Pointer, let's call it a pointer to it. Ah, shoot, what's this one? Steering behavior, pointer, yeah, that should be it. Okay, I can't do it this way, but we have it already here. We have a current steering behavior, so we're gonna just put that one in here. There we go. Next to that, we also need to add all the options, right? So we have a wander behavior, and we need to add that. I think that we have it already, so we can just do mp wander, and that's all we need for now. So that's in here. So then in our behavior tree, we can say hold on a minute. We get the wander behavior and then we set it to that. Okay, so how do we get that? We do p. This has to have a blackboard board pointer. It's an elite blackboard pointer. P data, I call it, and then p data dot get data, and then we say, okay, so you want to get a wander behavior, right? And then we need a way to store it. So we have a wander pointer, p wander, and we store it in there. But this function, it can also fail. So we wrap this in an if, and we say if that is a null pointer, then return failed, right? So if you can't find the value in our if you can't find the value in our brain, then this operation fails, right? That makes a bit more sense. And then what we need to do is we got our desired behavior. Now we need to set our current behavior to that. So we need to change some data in our brain. Which data? Well, the current behavior, the current steering, and we need to set that to what data exactly? Well, the wander behavior that we just got from our brain. So just telling the brain from, okay, I want you to do this behavior. So that's all we need to do. And then in our behavior tree, which is how our brain is gonna work, we're gonna add a new elite action, behavior action, and it's in the namespace of behavior tree actions. And which action is it? We set to wander. Is the music still too loud? Okay, that's a good note. Then I'll change that in a second. Let me just finish this line of code. I'm curious though, how much of this code, of me explaining this, can you actually understand? You think it's still too loud, so I'm gonna put it way back. Okay, it's probably too silent now. There we go. Good. Okay. So what's wrong here? Let's see what's wrong. Oh. You will lead behavior action. Oh yeah, that's a vector. No, it shouldn't be a vector. Hold on a minute. Set to 1 is like this. Oh, it's just the call, right? There we go. Figured it out eventually. Doesn't count as a build. Doesn't mean I have to eat the jelly bean. So now we tell the brain every single time, just wander around aimlessly. I want to change that. I want to put some structure into that. And to do that, we're gonna divide our world into a grid, and then we're gonna just go to the closest point on the grid that we have not visited yet, right? So first of all, we need to add that grid to our world because that is not standardly there. And to do that, I have a structure over here. It's called a cell, which takes a, let's put this at like the bottom. It has a center, a size, of course, then if you have visited or not, and then a cost, which is basically the distance to that cell. Still loud music, god damn it. Put it way down. That should work. Just tell me, Rosk, if it's still too loud. Okay, so now we need to make that grid. And again, we need to store that grid somehow. We're gonna put that in another vector. Gonna call it grid, so this is gonna have cells. Or mgrid, or yeah, let's call it mgrid, that makes more sense. Right, so now we need to fill this grid, and that's gonna be a little bit more tricky than you expect. But first of all, we also need to, let's check it here. We need to add that grid to our brain. There we go, so that the grid is also in our brain. So now the AI can access that variable. Okay, so first of all, we're gonna make that grid. So let's make that grid over here. So to do that, we first need to get a world information. World info, which we get from the interface. Let's do it from the interface by get world info, and it gets us back the world info, and this of course has the center of the world as well as the size of the world. I think it's the center of the world, right? So from the center of the world we need to construct a grid. And how we're gonna do that is just a bit more annoying than I would have liked. So first of all, we need to also, with our grid, we also need to define a number of rows. That's gonna be an integer in rows. Let's say like 15 rows, and then int columns, which will also be 15. So we only should have actually needed one variable for that, but it's good to separate your rows and columns into separate variables. Okay, so we know how much rows and columns, we know how big our world is, so we know how big each cell is. It's just division. So let's first put the size of each cell. Let's calculate that. So it's a vector that we're gonna make. Vector 2, because that's two component, and that's world info dot dimensions divided by m rows. No, that doesn't work. Dimensions dot x divided by m columns, and then the same but for our y direction, and we're gonna have to divide by our number of rows. Okay, so that's not good. We need to give this a name, so let's call it cell size. Okay, done, perfect. Okay. Now this gives us access to the center of the world, and we know how big each cell is, but now we need to calculate the center of each cell. And we need to do that for each cell, so we're gonna put that in a for loop, and we're gonna start at an index of 0, and then as long as the index is smaller to the number of rows times the number of columns. Should I put that? Yeah, we're gonna put that in a double for loop. So first we're gonna put that in a number of rows. Like this, and then we're gonna increase the rows. And then we're gonna copy this line. And we're gonna do the same for the columns. Right. So now there's the loop over each cell in our grid, and now we need to define the center of it. And that center will be starting at the world info dot dimensions dot center, of course. But that's not it. That's not all of it. Because we want to start in the bottom left and then work our way through. We don't want to start at the center of the screen and fill our arrays that way. That's stupid. So get the center of the world. Then we need to from that we need to go to the leftmost cell. So we're gonna subtract our dimensions from it. So the half of our dimensions, not too much, of course. On info dimensions dot x divided by 2. Same for the y direction, but then with the y variant. So we actually can do this in one step, because I think this is operated overloaded. Don't quote me on that. So world info dot dimensions divided by 2. There we go. So now we're in a top left cell, but that's the bottom left. So then we need to find the middle of that cell, which is quite easy, because that's just plus equals the dimensions cell size divided by 2. Okay, so now we're in our cell, but now we need to add a plus equals cell size dot x times our number of columns, and then the same for the y, but with our number of rows. And that's basically it. So we're gonna do some compacting here. So we're gonna subtract that here, like so, and then we're gonna add cell size divide by 2 here as well, so then we can get rid of these two lines, a bit more compact, and then we're gonna push back that value into our cell. So we're gonna make a cell with the values of, let's see, what's the cell center? So cell center, cell size, then true, false, sorry. And I don't think, does it have another value? Oh, and cost, which we'll just put at 0 for now. So that's our grid completed and stored as well. so now we need to add another behavior, because now we need to not aimlessly wander around, but we want to actually go to a certain point. So how I'm gonna do that is I'm gonna first add a new behavior, and that's called the seek behavior. And luckily I already have this one prepared as well. So the only thing we need to do is make the variable. Then in here we need to add that seek behavior as well. Okay, that's all done. And we need to delete it as well, can't forget that. Done. And then in the behaviors, we're gonna just copy this one and set to seek. But as you expect, like I said, we need to actually seek something. We need to seek a point. I think I actually made a mistake here. Oh no, I spelled it this way, but let's actually spell it the English way, the American way, so it's all the same. So this one, basic, okay, basic. So before we actually set that to the behavior, right, we need to, no, that actually works, kind of. Does that work? Yeah, we'll leave it for now, I think. But now we need to actually write some behavior. I want to add two behaviors, two actions here. One is reach target. No, that's actually a condition, so has reached target. So bootback has reached target. And I want another one called set target as well. But we're first going to go with has reached target, and for this we need not the seek behavior, but we need our target. It's an elite, damn it. So we need a target to store that. This can't be empty, so let's keep it this way. But that also means that we need to add a target to this list, right? So we're gonna do exactly that. Target. And we'll just leave it as an elite vector, but we'll leave it empty. Or just at 0, 0, that's fine. So we got our target. This should just return false. Okay. And then we also need to get something else, and that is our agent info. Because we need to know the position of our agents. Okay, and I think that's actually already in. Yes, it's already in our brain. So let's keep that. It also can't be empty. So now we're gonna give a float distance. And we're gonna put that really small, so let's just say like 0.5 if. That's half a unit. And let's check if that distance, so we're gonna return if that is small, the distance between the target and the agent. So that's actually a function that we can use. So we're gonna use the distance squared because that's faster. Woohoo. So we're gonna check target, the distance between the target and our agent. Position, and if that is lower than distance times distance, then it's true, otherwise it's false, and it will return that value. So for now, we're just gonna put another sequence in our tree. We're gonna actually put a selector in our tree, so a new elite behavior selector. And I actually haven't explained this behavior stuff, right? So what this does is make a new behavior selector, and the selector basically selects one of the options from it, and a sequence is just a sequence of events, and it needs to accomplish all of them to succeed, otherwise it will go to the it will fail, it will go back. So I want to either wander, but I first want to check no, I want to check if I have reached my target, I will wander, otherwise I will seek my target. So this is just a basic thing that we'll just test it to see if it works. PT condition has reached target. If it has reached the target, then we'll wander aimlessly around. If not, we'll go to the next option in our selector, which will be set to seek. But first of all, we need to set a target. Okay. So we need to make that behavior set target. So we gather No, actually we don't need that set to target. We're gonna do a different way. We're just gonna incorporate that target searching in or seek. So we're just automatically gonna search that. So we need to get our target. So I'm just gonna copy this code. There we go. Then before we change our current, we're gonna do set target. There we go. Boom. Okay, so what I want to do to test this out is actually save a target. So we're gonna add some other variables here, and we'll call them debug variables. Call it elite vector target. Yeah, target. Target. Okay, so I want this to always be the same. Always be the same as the one in our brain. So every frame, we're gonna in our collect data here, we're also gonna update variables. So we're gonna get that from and store it in that. Okay, so this one, because I want to be able to draw it to the screen so we can see it, right? So target, boom boom boom, and then assert false. So if you don't find it, we'll just say false, and this should call blackboards. And this, okay, that's all fine. So then we're gonna render our target. What color? Let's put it at yellow. Okay, so how do we do a draw again? P interface, draw point. Where do we want to draw it? At the place of our target. What size? Let's put it at 0.5. What color? So we do a elite vector 3. color. So this is RGB. So for yellow, we want red and green. Green, but no blue. And then at a depth of 0.2 should be fine. We're gonna build again, so if this fails... Oops. Oh no, it will fail. I noticed that. Hold on a minute. I did catch that. That doesn't count. Okay, it works. Okay, so it works. So now if we run this, I'll try and move it over in time. We get an error. Huh. Abort has been called. Okay, off-breaking. Where though? Line 30. Okay, line 30. Huh, what? Hold on a minute. Okay. Which file? Plugin 130. Okay. Thought so. So here, so it says that that value is not in the blackboard, but it is. Oh, if it doesn't work, oh shoot, we need to change that for all the others as well. If it doesn't work, or doesn't exist, doesn't work, doesn't exist. Let's change that, doesn't work, doesn't exist, doesn't work. Jesus, that could have been a costly mistake. So basically, I had all of them wrong. Okay. Good way that we incest them. Okay. Okay, so we're getting a warning here that the current steering of type Wander is not found, because that's... we need to cast that. Okay. So we need to cast that. I'm gonna do that with a static cast to AI steering behavior. And if I type that correctly, and I do that, that should work. It should just be a pointer. And then same for the seek probably. So let's do that as well. And brackets. Still succeeded. Okay, it's loading. Okay. So, you have not seen it, but let's pick an artificial point. Let's put it like 500, 500, something like that. And we should see our target, or our AI moving towards that point first, and then if it's reached it... Okay, that didn't work. Hold on a minute. We need to build it first. Hold on a minute. To build it again. Build succeeded, and then if we run it again. Okay, so we can see, where is our dot here? Our yellow dot is over here. And this one should actually go towards it, but it doesn't seem to go there. Now why is that? Now we need to figure out some of this. So what are we actually doing? So we're gonna check, does it reach the target? If so, set to wander. If not, set to seek. So it's always doing this, so that means that the has reached target returns true, because return if the distance between the target and our agent dot position is less than the distance, or the distance squared. So let's actually check this out and see what this does. Start. So it should get there. Okay, so it's there. So the distance is 0.5. The target is this. Agent position is this. So the distance squared should give back. Okay, let's see. Distance squared gave back. I missed it. Can we go back a step? Apparently not. So let's rerun it. Okay. So distance squared. Squares that. Distance squared gives like 50,000. So this returns false, right? So it's a failure. So we check the next child, which is a seek behavior. Oh, that apparently returns failure. Okay, so that means I made a spelling typo and our seek behavior probably. Be seek. Oh, I didn't create the seek behavior. Okay, so mp seek is a new seek, of course, yeah. Otherwise it's pointing at 0, at nothing, and that's why it failed. Okay. So now it should work. Okay. Let's actually run it without the breakpoint and see. Okay, so now it's definitely trying. Oh no, it's still wandering around aimlessly while it still has that point it needs to get to. So why now? Why now? Let's see if it gets to this board. Should get there every frame, so it gets here, it gets a seek behavior, it does that, it changes the data, returns success, okay, so then it should work. So why is it not? Huh. Okay, let's check if it ever gets to the wander point before. It's not seeking though. It's just wandering around. Okay, I'm gonna have to... Give me a minute, people. Let's see why it's not working. Give me a minute. I don't know. Ah, what? No, just go away. So I cast it. Do exactly the same thing, I think. Oh wait, it could be that it's working. Hold on, I need to check something. Nope. Okay. Did I build again? I don't know if I did or not. Doesn't seem to build. Okay, build. It succeeded the build. Still just moving around randomly when it should actually seek. This is killing me. I get it. Okay. So we don't get the new steering from the blackboard. That's it. Current steering. And we put this in this variable. Okay. Build. And now it should work. Oh, stupid mistakes. Man. Yes. Now you can see it going all the way over there, right? It's going in a straight line there. But one problem I did see, however, first of all, let's make that point a little bit closer by so we can actually see it reaching that point. But one thing I did notice is that it runs into buildings and stuff, and we can actually fix that really easily by saying factor 2 elite vector 2 goal is basically our mp current steering dot get target. So we're gonna get the target, then we're gonna do the same thing, oops, but now we're gonna call it nav goal because it has a navigation graph, navigation mesh thingy, and then we can actually get from the interface, get closest the closest point on that mesh from our goal points, right? So you want to reach that goal point, but then we need to evade the buildings, and this function will give us the closest point on that path, and then it will go through all of those points until it reaches the goal. So now we need to set the goal, of course. We need to set our target again to that new navigation goal. And then after we calculated the steering, we need to set it back to our original goal. Really roundabout way of doing it, but basically we're just temporarily setting our steering behavior to target a closer point to eventually get to the further points. So if we build, this should all work. Nice. Okay, start. Okay. So now it will evade this corner and then turn and go towards our target, and once it reaches our target, it should... Ah, shoot. Okay. So it should have reached this target, right? So let's actually check. Can we check it before it dies? Okay, so we got that target before it dies. So Our distance squared is very small, so that might be an issue. So let's see how close it actually gets. Okay, it gets, that's really far still. Oh, okay, I know why. We don't update our agent position, of course. Oh, stupid, 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 stupid. Okay. So here, so we get our agent info here, right? And then we're also gonna push that information to the blackboard. Change data or agent info. We want to change that to this agent info. Okay, and I also want to add another debug. I want to add another target. This time it will be the nav targets. Okay, and the nav target will be nav target. Okay, will be equal to this, right? And then this goal, we can actually set that to our target, right? That should be the same thing. Okay, and then that should be targets and nav targets and goal and goal. And then we're gonna copy this and we'll add a blue point or sign for our nav target. What the heck is this? So cyan is this. Build it. Hopefully it builds from the first time. Succeeded. There we go. And there we go. Aha, okay. I made a mistake. Because I think... No. Oh, agent info with a capital letter. Okay, so this needs to be a capital letter. Okay. It builds. Let's run it. Okay, so now you can see that's our nav target, and then it turns there, and once it reaches that, it should hopefully okay, I see what's going on here. We don't set. Okay, I see what's going on. Okay, that's no biggie. Okay, that's fine. Whew. Okay. Ooh, Jesus, that took me a long time just to do that though. Ooh, God. Okay, so next thing I want to do is so we have that grid, right? So I want to get the closest one, and I want to put that in a list of targets, because I'm going to use that list later on as well. So what I want to do is create a new vector, and I call it targets. I'm going to make a new struct called valid targets. Targets. Okay, so I'm gonna make a new struct valid targets, and in that struct we're gonna have an elite vector target, and then a bool is valid. And we call it false. Okay. So now we got our targets here. Okay. Again, I need this information in our brain, so we're gonna add a new targets. Targets. Okay, so that's all in there. Good. Now I need to get a target, add that to that vector, and then oh Jesus, how I'm gonna do this? Because I want to have, okay. So basically, if I have reached the target, I want to invalidate the target, and then if it's invalid, I will pick a new one. But the picking will be happening outside of the brain, right? Oh, Jesus, this is difficult. Oh, we first need a new function, update grids. Update grid. Okay, let's make a function update grid that loops over the whole grid. But we also need the agent information. Luckily, we have that agent information stored in an agent. Or is it just agent info? We don't have it stored now, do we? We're gonna store it. It's gonna be a data variable. Agent info. m.agent info. Okay, so we got all the agent info. Update grid. So we got the agent info now. Okay, good. So we need to calculate something here. We need to calculate the cost of our cell if it is already visited, right? Oh, Jesus. So for each cell in our grid, we need to check if the cell is visited. If it's not visited, because if it's visited, we don't care about the cell anymore. But if it's not visited, then we need to update the cost. So I'm gonna set the cell.cost equal to the distance between the distance squared from the player, which is an agent info. Oops. The position and the cell.center. Okay, so we updated the cost, but then we also need to check if that distance squared. Okay, so actually we need to save that distance. Because we're gonna use it again. Okay, so distance squared, we're gonna set the cost equal to that, and if that distance squared is very small, so let's say less than let's go at a 5-point radius. No, we can't actually set it to the cell size. Let's set it to. No, we need to make this like a the minimum of the cell size dot x and the cell size y, and we need to multiply it because it's the distance squared, right? and then we need to divide that by 2, and you as well. Okay, so that's, if that's true, then we're gonna set the cell.visited to true, because that means that we're close enough to the cell that we actually visited the cell. So we did that, but first of all, before we can actually do that, we need to get the information from our blackboards. Grid, and we're going to store it in this variable, and then after that function we need to put it back into the blackboard because we updated the data. So then we're going to say grid to empty the grid. Okay, good. Okay, so now what we're gonna do is rewrite a behavior. And we're gonna do has unvisited cell. And what this one is gonna do is it's gonna look through our array of our grid, and it's gonna check. Is it a vector of cells, please? Grid. So it's gonna check our grid, check if they're visited or not, and if they are not visited, then we are gonna set our targets, right? Okay. So we don't need this for now. Okay, so we need our grid. So let's first check. Okay, so we need to loop over the whole grid again, but I don't like that. I don't like doing that. So we're gonna write it using algorithms, I think. So first thing we need to do is find if it's unvisited. That means that there are unvisited cells, and then we need to find the closest one. It's gonna be difficult. Copyf will work. Oh yeah, copyf will work. Okay, so we're gonna make another vector of floats. And what this is gonna do is it's gonna generate. No, it's gonna copyf. Yes. Transform if. Copy if. Transform if. Transform if. That's gonna be the. Copy if. I don't know. I wanna make this really simple, right? Actually, no, we can't. We can't make it very simple. We need to just sort them. Okay, so we need to copy if. So we're gonna have a vector of cells. Unvisited grid. And we're gonna initialize that. And then we're gonna unvisited grid. Dot resize. We need to make it at least the size of the grid. Okay, and then we're gonna do a std copy if. So we're gonna copy the values from our grid.begin and our grid.end. I'm gonna copy those over to our unvisited cells dot begin. We're gonna only do that if, and then we're gonna do this again. O2 element. Okay, and then we're gonna only copy if, and then we return if element dot visited and only if not visited elements. So we're gonna copy all of the not visited elements. We also need to erase everything. Grid.erase everything from that point until like unvisited.end. Okay, so that's all that. That's some cool code. That's cool. Okay, so now we have an array with all of the unvisited cells. Now we need to sort that array, which is really easy. Just gonna write std sort, and we're gonna say unvisited cells dot begin, and also again dot end. And then we need to add our predicate for how we're going to sort them. So again, not this, not this. We're going to have auto element 1 and auto element 2, I think. And then I need to check, but I think it's lesser than. So we're just going to say element dot cost is lesser than return. Cost is lesser than element 2 dot cost. Okay. Okay, so now our array is sorted, and our first element is the one with the smallest cost. So that will be our target for that target vector that we have made. But for now, we're just only going to use one target. So I'm just going to not care about that vector yet and just say pre-data.change data and change our target to the first visited cells, investigative grid, the first element, and then we want the center, of course. And that should all work. So now, in our brain, in our decision-making structure, if it has reached the target, okay, so I want to check. Do we have reached the target? Okay. Okay, so this is gonna be a little bit difficult. So, if I have reached the target, then I will check, do I have unvisited cells? Has unvisited cells. Okay, well, that will set to seek. Otherwise, we'll wander. Okay. Now, the problem is it will start in wander, so we're gonna start it off in... No, it will start off in wander, but this should say reach target, so we're gonna set the target back to 0, 0, which is where we spawn, I think. I hope. Could basically set it to the world to agent position as well, but we'll do it this way. Okay, let's see if I made any mistakes with the template stuff. I don't think I have. I didn't. Okay, perfect. Okay, so let's see if it actually works. So now it should. It did a debug assert. Okay, offbreak. Where is my mistake? It doesn't show. Let's try it again. Vector subscript out of range. Interesting. Okay. So that means I made a mistake somewhere over here. Okay, so copy of grid and unvisited grid. Okay. Unvisited grid and Okay, let's see the sort functionality if that works. Std sorts. Totally not looking up sort now. No, that should work. Okay, let's see where it is out of range now. What is this? Help. Grid size. Okay. We size it, we erase, we copy if, begin and end, we set it begin. What is this though? This floating it, oh, that's gonna bug me forever. Okay, so let's see where it actually crashes. So we're gonna put a breakpoint there. So we'll see if it gets to that first point before it breaks. Okay, so it makes that work. So we continue. Okay, so that works. We continue. Okay. Okay, I should have added a breakpoint there. Let's try that again. Okay, so that works. That works. Is it that not working? Huh. Itself is automatically false, right? Okay, so we're gonna put a breakpoint here again, and I want to see the size of our unvisited grid. Size of 0. Okay, that's worrying. Okay, we're gonna start at the beginning then. Let's see what's happening here. Okay, our grid is empty. Why is our grid empty? We basically made a whole grid here. Okay. And then grid, and then change that to grid. Okay, so oh, we never pushed it back into the grid. Okay, I can see now. The pushback, it would be helpful if the cell is of course in the grid. Okay. Success. Starting it. Okay. Grid has a size. Unvisited grid had the right size, so we continue. Let's see. My target is over here, which is weird. I'm wandering aimlessly, so that's wrong. Okay. Let's see. Oh, that should return something, right? Okay. So if unvisited grid.size is bigger than 0, then we change the data and then we return true. Otherwise, we return false, of course. And now hopefully we should see it work. I think it's still wandering. Yes, it's not going towards the target at all. Okay. So let's see if it actually gets to the seeking here. Oh, I see what's happening. Okay, I see what's happening. Okay. I think I know what to do. No, I don't. Wait, hold on a minute. This is where it is a little bit annoying now, because I don't need anything to change, but it's picking wander. If it has not reached the target, it should just keep going, right? So how do we fix that? So this is the grid scanning. Let's call it grid scanning. Okay. It has reached the target, then I should invalidate the target as well. Oh, this is gonna be so tricky to do. How late is it? Oh god. My brain is dying over here. I know we didn't do too much today and I only... Oh god. I'm tired. Did I mention I had an exam today? I'm very tired. Jesus. It's tricky, right? Because we don't need anything to change. It's hold on a minute. Because I'm thinking about, I know what's coming as well, so I'm thinking about how we could make this in the most optimal way. So if it has reached the target, we need to find a new target. Otherwise, we just keep going to seeking, right? Would be the same as just doing this, right? So let's keep it at this, and that's grid scanning. If we reach a target, find a new one, otherwise just keep seeking. Okay, so where are you going now? Why is it going to that one? Oh, because that cost is Oh, Jesus, come on, man. Let's put this first, so it's basically always gonna target the closest cell. Jesus. Oh, it's always gonna update the closest cell, so it's always gonna update the target. Okay, now I know it will not work exactly as I intended. It will just go to the Why is it still going to that one? Jesus. Why? Ah. I think... No, I want to get this working. God damn it, I want to get this working. Let's check it. Has invested cell. Let's check how this is sorted, right? Let's check what this is. Let's see how it sorts itself out. And let's see if it's the wrong way around. Oh yeah, it's stuck there. So invested cell. The first one is the one with a cost of 0. Continue. Still a cost of 0. Why is the cost 0? Are we not updating the cost every frame? We are, right? Oh, did I add that function? I did not. Okay, that explains a lot. So we need to update our grid as well. Okay. Cost of 0 still. Okay, next frame. Cost of 0, cost of 0, cost of 0. Why is it still cost of 0? Jesus. Let's check this. Continue. Let's step into this function. No, distance is always positive. Why is it not working? I'm hopeless at this point. I'm just watching the code go. So that's a value. Yes. Oh, I get it. Okay. Stupid me. Of course, that should be a reference. Stupid mistakes. Those small things will cost me my life one day. Come on, load. Oh. Come on, load in. Just trying to get to that point. Just trying to get to the next one. Okay, so it seems to be working. So let's check out if it's actually working. Let's actually draw the whole grid out. So, draw grid. Now I only want to target the center of the screen, so we're gonna do a for each cell in our grid, And then we're gonna draw a point, of course. Let's be a bit fancy. So draw a point, cell dot center, of course. Okay, let's give it a bit of size, and then we're gonna make it. We're gonna add a elite vector here. Vector 3, color, and then we're gonna be fancy. So let's say that cell dot visited is equal. If cell dot visited, then we'll do green. Otherwise, we'll do red. And red is this. Okay, so we need another bracket here, there, and then color. Now they should all be red, of course, because we're not checking if we reached it, and then we're not actually invalidating the target. We're not saying like you're done. But this will show us the grid. Oh, it actually gives that one visited, and it gives that one visited as well. It's actually working. It's actually working. We don't need to. Oh, we don't need to, of course. So it's picking the closest one every single time. So you can see this one will turn green any second. The next one. So that's actually working. We actually got a bot that's going through the map, and it's saving every single data that it's finds. So now we need to give it some other ideas, other techniques, but I think we don't have much time. So I wanted to maybe get the priority system in, but we'll probably not be able to do that even. I can see it like getting away from the... Let's see if this bot can actually get to a score of 100. That would be cool. You know what, let's make it interesting. If it does, I'll need another bean, because I have only 8 and 1 bean this whole stream. You can say all I want about me maybe not being too good in coding. It's getting close. Only like a couple more seconds. Oh, oof. I think it's gonna die first. 10 more seconds. It's only got like 4 health. Ooh, it's gonna be close. Uh-oh, there's another zombie incoming though. 9. 100. Hey, it got there. Perfect. Okay, so that means I'll grab another bean now. Okay, let's close it down though. Actually, let's just keep it going. Oh, it died at 116. Okay, nice. Okay, let's grab another bean now. Okay. Let's go up. I got my bag here. Probably gonna keep this challenge going. Why is it so dark? Come on, light up. Stupid webcam. Wait, hold on. There we go. That's better. A little bit though. Oh, we got like 17. Hold on a minute. Let's put the rest back again. I think I'm gonna pick the red one. Hold on a minute. Okay. So it gotta be. Can you come on? Light up. It's red. Okay, it's red. Let's see that. I have no idea what this is. Okay. I think, according to the bag, oh god, that was awful. I think that was either dirt or earthworm. I don't know. Like, it's not that clear between the two. It tastes a lot like dirt, but I guess earthworm would also taste a lot like dirt. Oh, has a bad aftertaste though. Whew, okay, we survived that. Do I want to add something else though? Like, we got a grid all working, right? So I want to... Do I want to do anything else? I don't think so. Like, basically this is one thing. And then we're gonna add priorities on top of that. So next priority would be, if we find a house, go to the house, right? And that's why I made the vector of targets, right? So we're gonna always keep the closest cell in that target. And then based on the array, if the target in there is valid, we'll go to that, look to the one with the highest priority, right? The first one in the array. So the first one will be like evading enemies, then items, then go to the houses, and all of that fails, just target the grid. And then all of that fails, fucking, I don't know, go to wonder, right? Good, okay, that's, yeah, I think we'll call it a day. Here, I don't have time to add like anything else. I think it'll take me like more than half an hour to add something else. Yeah, so we'll round it off here. Should I try one more berry? I don't know. I think we'll give it one more berry. One more bean, right? Just because I opened this package. I took the top one. Here it is. It's pink. I'll actually change the scene again, just like I changed. Okay, so here it is, now in its full glory. It's a pink bean. Let's eat it. Oh, this is good. Yes. That's a good one. It's very tasty. Yes. I think that was tutti frutti. This is a fun thing. Good, okay. Well, anyway, I will have to end the stream here. I'm tired, I need some rest. I'm working on this project again tomorrow, so maybe I will be streaming it again. I don't know for sure though. I'll probably be a little bit quicker if I just do it off camera. But yeah, next week we'll do a normal stream hopefully, so we'll be back on Minecraft. Anyway, there's some beans stuck in my teeth now. Anyway, if you liked it, hit that like button, comment, subscribe, all that good stuff, and come back next week and I'll see you then. Goodbye. It's been a while. Where's that stop streaming button? Hold on a minute. I need to click this one. Yes, and then end. There we go.